Welcome. This is the continuation of Dynamic Worksheet 4B, Forces on an Inclined Plane with Friction, and this is a work through of question 9. So question 9 is just a modification of what we've already been doing, except this time we're moving up the hill. So we've got a 750 kilogram car and it's going up a hill at an incline of 12 degrees, and the overall acceleration in the upward direction is 0.75, 3/4 of a metre per second squared. The road surface has a kinetic friction value because it's called kinetic friction because it's moving, and it's the value of that value is 0.6. So let's see what we do and how we can answer these two questions. The first one is explaining why the friction in this case is in the opposite direction than all the other cases, which is up the hill. Okay, so in this case it's down the plane. So why? So let's have a look at what's going on here. So here's our plane and here is our car. And this time the car is going up the plane there, and the acceleration of that is 0.75 meters per second squared. Okay. So one fundamental thing that we need to remember about friction is that it always opposes the motion. So if we are moving up the plane, then we must have a frictional force, in this case F little k, going down the plane. And it's friction with kinetic because it's moving. So this is a different type of friction. It's not the static friction. And this would be equaling to mu k times the normal force. And we know the normal force is given as mg cos theta. So that's mu k mg cos theta. Now, in this case, the theta is 12 degrees. So we put that one in there as well. We know that the mass of this car here is 750 kilograms. Right, we probably got enough now to answer the second part. So the part one was why is it down the plane? Simply that friction must oppose motion. So if the motion is up the plane, then the friction must be down the plane. Okay, so we're going to calculate the driving force. This is number 2. Calculate the driving force that is actually on this car. Well, the overall net force, that's the force net, must be able to create an acceleration of that, which is 0.75. So that would cause, that's going to be MA, and this is 750 times 0.75. And I have mislaid my calculator. Just give me 5 seconds. There we are. On the other desk. Okay, and it was 750 times 0.75. And that is a force that is needed. Oops. Well, just retype that in. It's just playing up. There it is. It is 562.5 newtons. Okay, rightio. So that's the overall force that we need. But the force that is actually on this car are two forces. There's a force going up and there is a force coming down. So that force going down the plane here is not just this, it is also equal to, so the forces down the plane, down, would be friction plus the downward force of mg sine theta. Okay, so remember, it's not just this, even though my arrow here has got friction, that's the frictional force, but it also has this component of weight going down the page. So let's actually have a look at what is the value of that down the page. That is, it's going to be mu, let's just put it out as in algebra for the time being. Let's just move that around so we get a good thing. So it's mu k mg cos theta plus mg sine theta. So grouping those two together, that's mg goes outside of mu k cos theta plus sine theta. Okay. And let's put all the values in there now because we know these. I just might move slightly sideways so I don't run out of room. So that would equal the mass of this car is 750 times 9.8, and mu is given as 0.6 cos of theta, so it's cos of 12 plus sine of 12. Okay, so let's work those out. So putting this into our calculator now. We've got 750 times 9.8. Sorry, I can't see that one. That's better. Times 0.6 times cos of 12 plus sine of 12. So that is a force of 5841.8 newtons. Okay. So we have a force going down the plane of this amount of newtons. We need a net force up the plane of this many newtons. So how much does the engine need to push? So we've got, here we go, we've got going down the plane is 5841.8. We need an overall of 562.5 newtons. So what is this value here? Okay, how would we calculate that? Well, this number here must be that much more than that number there. Okay, so the total force, so the driving force, this is the engine force, must be bigger than 841.8 by 562.5 newtons. So adding those two together, we get, let's put it together, 5841.8 plus 562.5. It's 6,404.3 newtons driving force from the engine. Okay, yeah, I hope that helps.